Imagine standing on a beach at noon. The sky is clear, the sun is blazing, and waves crash gently at your feet. Everything looks normal until it isn't. Because suddenly, without warning, every ocean, lake, and river on Earth becomes invisible to ultraviolet light. At first, no one notices. Water still looks blue to your eyes. It still feels cool to the touch. But something deadly is happening beneath the surface, something that the human eye cannot detect. All your life, you've relied on a simple fact of nature. Water blocks most UV radiation, protecting everything beneath it. Marine life, underwater ecosystems, even submerged objects, all of them depend on this natural UV shield. But now, that shield is gone. Within minutes, sunlight spears through the oceans with a new, unforgiving sharpness. UV rays blast downward for hundreds of meters, striking creatures and environments that were never meant to experience this raw radiation.
Phytoplankton.
The microscopic plants that produce half of Earth's oxygen start dying almost instantly. Coral reefs begin to bleach at a speed faster than anything ever recorded. Schools of fish dive deeper and deeper, only to discover that there's nowhere left to hide. And while all of this unfolds below the surface, people on the coast begin to see something terrifying. The ocean is glowing. A surreal, eerie radiance spreads across the water as UV light passes through and reflects off suspended particles like a cosmic spotlight beneath the waves. Earth has just entered a new era, one no species is prepared for. Please like this video, subscribe to the channel, and comment your question below. Water is one of the most remarkable substances in the universe. It shapes planets, supports life, and protects entire ecosystems. But one of its most overlooked abilities is its power to absorb ultraviolet radiation. This natural UV shielding is the reason life could evolve beneath the oceans billions of years ago. It's why shallow reefs can survive intense sunlight. It's why marine organisms can grow, reproduce, and thrive without being burned by radiation they were never built to handle. But in this hypothetical scenario, we remove one critical property. What if water suddenly became transparent to UV light? Not just a little bit transparent, completely transparent, allowing intense ultraviolet rays to pass straight through from the surface to the deepest trenches. Oceans would no longer be protective blankets, they would become giant transparent lenses, focusing, scattering, and transmitting radiation in ways Earth has never experienced. Why is this scenario scientifically interesting? Because water's UV absorption influences chemistry, biology, climate, and even the evolution of life itself. Removing this property would unravel a delicate balance that Earth has maintained for over 3.5 billion years. In the rest of this video, we'll explore how this transformation unfolds step by step, beginning with the immediate biological shock, then the environmental chain reactions, and finally, what Earth looks like in the long run. Prepare for a scenario far more extreme than most people imagine.
The moment water becomes transparent to UV light, the first and most devastating consequence hits the foundation of Earth's marine ecosystem, the destruction of surface life.
Let's start at the top of the water column. Normally, UV rays penetrate only a few meters before being absorbed. But now, with water no longer blocking them, UVB and UVC radiation shoot downward for hundreds, possibly thousands of meters. This instantly turns the upper ocean into a high-energy radiation zone. The first casualties are the most important ones: phytoplankton. These microscopic organisms perform photosynthesis like plants, generating roughly 50% of the oxygen in Earth's atmosphere. But they evolved under the assumption that water would shield them from harsh UV. Remove that protection, and their delicate cells suffer DNA damage within minutes. Many species die outright. Others attempt to sink deeper, but UV radiation now follows them down, leaving no safe refuge. Without phytoplankton, the entire marine food web collapses. Zooplankton starve. Small fish lose their primary food source. Larger predators, tuna, sharks, whales, find the ocean strangely empty, forcing them to migrate or perish. Coral reefs, already sensitive to heat and pollutants, now face radiation exposure far beyond their tolerance. Corals rely on symbiotic algae called zooxanthellae, which are even more vulnerable to UV damage. As these algae die, reefs bleach not over weeks or months, but in hours. The most biodiverse ecosystems on Earth become ghostly white deserts. Even underwater geology begins to look surreal. With UV penetrating deep water, minerals on the sea floor fluoresce in unexpected colors: greens, blues, purples, creating an eerie alien glow. But while beautiful, it's a sign of unnatural levels of energy passing through places that were once shielded in darkness. In this new reality, the ocean's surface no longer represents life. It represents danger. Everything that evolved with the assumption of natural UV protection is suddenly exposed, vulnerable and struggling to survive. As marine life collapses, a second wave of consequences begins, this time targeting Earth's climate and atmospheric chemistry. Because when water stops absorbing ultraviolet light, The oceans don't just become deadly, they become gigantic radiation amplifiers. Let's start with the surface. Under normal conditions, UV rays are absorbed or scattered by water molecules in the top few meters of the ocean. But now, those same rays travel deep, hitting suspended particles, tiny organisms, sediments, salts, and even dissolved organic matter. Each interaction causes UV scattering, sending radiation back upward in unpredictable directions. The result? A continuous upward glow of reflected UV, almost like the ocean has turned into a massive UV mirror. Coastal cities experience spikes in UV exposure even when not in direct sunlight. People standing near beaches or lakes receive higher radiation doses simply because the water is reflecting and re emitting UV from below. This begins a chain reaction. First, massive ozone depletion. With plankton dying off, the production of dimethyl sulfide, an important compound that helps form reflective clouds, plummets. Fewer clouds mean more UV reaches the surface. More UV means hotter oceans. Hotter oceans release less CO10 but absorb more heat, disrupting global wind patterns. Second, the sudden collapse of phytoplankton triggers a major carbon imbalance. Normally, these organisms absorb huge amounts of carbon dioxide. Without them, atmospheric CO2 rises sharply. This accelerates global warming at a pace far faster than human emissions alone. Third, weather systems shift violently. With the oceans now warming unevenly, UV penetrating deep in some regions but not others, currents destabilize. The Gulf Stream slows. Monsoon cycles break down. Storms become chaotic and unpredictable because the ocean atmosphere energy exchange no longer follows the patterns Earth has relied on for millennia. And then the final twist. Deep ocean layers begin heating from below as UV rays reach depths that have remained cold for millions of years. This stirs ancient sediments, methane hydrates, and volcanic deposits, releasing methane bursts into the atmosphere, one of the strongest greenhouse gases known. In just a few years, Earth's climate becomes unrecognizable. With ecosystems collapsing and the climate spiraling out of control, Earth now enters the long term phase of this transformation, one that reshapes the entire planet over decades, centuries, and eventually millennia. The most immediate long term result is the permanent restructuring of marine life. Species that depend on sunlight, such as phytoplankton, seaweed, corals, and nearly all shallow water organisms, vanish almost completely. What remains is a world dominated by deep sea extremophiles, creatures that never relied on sunlight or photosynthesis to begin with. Hydrothermal vent ecosystems, for example, suddenly become Earth's new biological hubs. These communities don't need sunlight at all, they survive on chemical energy from the planet's interior. In a world where UV light penetrates the entire ocean, life gradually retreats toward these deep, dark oases. Over thousands of years, evolution might reshape these organisms into bizarre, hardened forms adapted to a world where the surface is a radiation desert. Meanwhile, Earth's atmosphere continues drifting toward instability. Without the balancing effect of marine photosynthesis, oxygen levels decline slowly but steadily. Humanity wouldn't suffocate quickly, but within a few centuries, oxygen scarcity would become a noticeable stressor. High altitude regions would become dangerous, wildfires more frequent, and aerobic organisms less efficient. Coastal landscapes also transform. With UV penetrating deep water, algae mats no longer bloom, causing coastlines to lose their natural filtration systems. Beaches erode faster, sediments break apart, and coastlines become barren and sterile. Most shocking of all is the long term thermal shift of the oceans. As UV energy diffuses evenly through the water column, deep oceans warm something that normally takes tens of thousands of years. Warmer deep water rises, altering global circulation patterns in ways scientists can barely predict. This could end the thermohaline circulation altogether, plunging some regions into permanent cold and others into perpetual, unbroken heat. Human survival becomes a question of adaptation. Cities move inland. Agriculture shifts to controlled environments. Oceans become places to avoid, not admire. Earth remains habitable but fundamentally altered, an alien version of the world we once knew. In this hypothetical world, a single change in one of water's physical properties reshaped the entire planet. By becoming transparent to ultraviolet light, the oceans lost their most important function: protection. What followed was a cascading collapse of biology, climate stability, and global ecosystems. First, the immediate destruction of phytoplankton removed the foundation of the marine food chain. Coral reefs died within hours, fish populations disappeared, and the oceans became silent. Without these microscopic organisms absorbing carbon and producing oxygen, atmospheric chemistry tilted out of balance. CO2 rose sharply, oxygen levels slipped, and Earth's climate accelerated into a chaotic transformation. Then, as UV light penetrated deeper, the oceans themselves turned into energy sinks, heating from the bottom up, destabilizing currents, and triggering methane releases from ancient seafloor deposits. Weather systems broke down, coastlines eroded, entire regions faced extreme heat or permanent cold. Over centuries, life retreated into the deepest, darkest environments, evolving into forms adapted to a world without the protection water once provided. Humanity could survive, but only through technology, controlled environments, and massive adaptation. The familiar blue planet would slowly shift into a harsher, stranger world, one that feels more like a distant exoplanet than the Earth we know. The Richter scale, which has technically been replaced by the moment magnitude scale, measures the strength of an earthquake. Since we usually hear about earthquakes as ratings somewhere between 3 and 9, a lot of people probably think of 10 as the top of the scale and 0 as the bottom. In fact, there is no top or bottom to the scale. But even if 10 isn't the top of the scale, it might as well be. A magnitude 9 earthquake already measurably alters the rotation of the Earth. The two magnitude 9 plus earthquakes this century both altered the length of the day by a tiniest stem. Sometimes the smallest properties of matter, things we never think about, are exactly what make life possible. A tiny change can create an entirely different universe.